Hello, everyone. I didn't get to the topic of the area formula in class for homework 11 this week, so I wanted to make a quick video to help you with that. Okay, so area for oblique triangles. You may remember from geometry that the area of a triangle is 1/2 base times height. Now that works for any triangle, whether you are right or oblique. But with oblique triangles, we can actually kind of refine this formula and make it look the way, just make it look a certain way so that it's nice and useful for us in an oblique case. All right, so I'm going to make a triangle here, kind of the way that we're used to seeing it with an A, B, and a C. Actually, let me name name this just for the purposes of keeping this as simple as possible. Okay, I'm going to relabel it this way with A over here on the left, B as my top angle, and C here on the right. Again, this side is A. What that does is it allows little b to be the base of my triangle. That way we don't get confused between side B and this B, which is the base of our triangle. That way side B and base B will be the same letter. Okay, so this is our triangle, and for our area formula, 1/2 base times height. The base is the length of the side on the bottom, which here is our B. So the base here and the little b here are the same B. Now height. The height comes from an altitude that is dropped down so that it is perpendicular to your base. Your height here needs to be perpendicular. So that's what h is. And we can actually express the height of h related to the sides of our triangle and the angles inside our triangle. So let's say I'm looking at this red triangle over here on the left, just this small right triangle here on the left. So here in this triangle, do you agree that if I look at angle A, I have, actually, let me keep this in red. I have that the sine of angle A in this little red triangle is opposite, which is height, divided by the hypotenuse, which is C. Right, I can do that in this little triangle because it is a right triangle. So I've got SOHCAHTOA. Um, and so if I multiply both sides by C here, then I get H is equal to C times the sine of angle A. And so I can plug that back into my area formula here, and I can say that area is then 1/2 my base, which in my picture is side B, times my height, which we just calculated to be C, times the sine of angle A. And similarly, we could also do this in another triangle. Let me switch, I'll switch to green here. If I switch to this triangle here on the right, again, this is a right triangle, so we have SOHCAHTOA over here. I could have also used angle C to do this. And I could have said that the sine of angle C is equal to the opposite side, which is H, divided by, all right, that looks a little weird to me, H divided by my hypotenuse, which is A. Again, I can multiply both sides by that denominator to clear my fraction, and I get that H is also equal to A times the sine of angle C. So I could also have written my area as 1/2 times the base, which is B, times my height, which this time we wrote as A times the sine of angle C. Again, these are just two alternative formulas. You can use one or the other. You do not need to use both. And just like most of our formulas that we've been working with, these are really, they kind of all say the same thing. It's just kind of in a different labeling scheme. or using different angles here. And we could do something similar and kind of relabel everything, or basically use side C as our base here and drop something down to use angle B. But basically we would get, if we wanted to use the sign of angle B here, we could have done 1/2 times A times C times the sine of angle B. This would be another way to calculate your area. So again, this really just boils down to 1/2 base times height, which we are familiar with. But these are three kind of different formulas for calculating the area of an oblique triangle. So let's try this. I'm going to start with number 2 because this is going to lend itself to what we just did. Number 1's a little different. We'll come back to that. So if I'm doing the area of number 2 here, first thing I'm going to do is label my triangle. You can really label these any way that you would like. I will do A here, B here, angle C here, which means this is side C, this is side A, this is side B. So if I want to calculate the area of this triangle in number 2, I have side B, I have side A, and I have angle C. So I'm going to choose the area formula that has the information that I'm given, which is side A, side B, and angle C. I'm going to choose this middle formula. So to find my area down here, I'm going to do 1/2 times A times B times the sine of angle C. Again, you can multiply in any order. I switched A and B here. For some reason, my brain likes it better in alphabetical order, so I just reorganized here a little bit. All right, so let's plug in what we have. This means our area is going to be 1/2 side A, which is 12, times side B, which is 7, times the sine of angle C, which is 144 degrees. And I can put this in a calculator. And when I do, I will end up with 24.69. And again, we have units here, so I'm going to go ahead and put units in. My sides are in centimeters. Area is in square units, so this will be in square centimeters. So that's how we calculate the area of an oblique triangle. Just label your triangle, choose the formula with the information that you're given, and plug everything in, and you have the area of a triangle. All right, let's go to number 1 here. Number 1 is slightly different because this is actually a right triangle. And since this is a right triangle, we actually don't need these this area formula for oblique triangles that we just did. To do the area of a right triangle, we are going to kind of stick with the 1/2 base times height situation, where your base will be the one on the bottom, your height will be the tall, kind of the vertical one that's perpendicular to your base. Because these two are perpendicular already, we can use this side as our base and this side as our height, and just use our 1/2 base times height formula. But in order to do this, we have to figure out what our base length is. All we're given is that our height over here is 15, and I know that this angle is 50 degrees. I do not know what my base is. So that's the first thing that we have to figure out. But we have trig. This is a right triangle. This is not an oblique triangle. It's right, which means we have SOHCAHTOA. We have trig at our disposal. I can use what I know to help with this. The trig formula that links this 50-degree angle, this side B over here and this side H over here, is tangent, right? Tangent is opposite over adjacent. So the tangent of 50 degrees is opposite, which is that B value that we have, divided by our It's opposite over adjacent. The adjacent side is h, which is 15. So I'm going to multiply that over, and 15 times the tangent of 50 degrees is going to be equal to my base. Again, just multiplied both sides by 15 to get to this last step here. And so now I can plug in what I have here. 1/2 base times height is going to be 1/2. My base is 15 times the tangent of 50 degrees times my height, which is 15. And I can plug all of that into a calculator, and I will get 134.07. This one doesn't have units on it, so I'm just going to say units squared because we don't have units. But if we did, it'd be whatever your units are squared. All right, so that's the area formula. I hope that was helpful for you for that last topic. Have a lovely weekend. Homework 11 is due on Sunday at midnight, and I'll see you next week for homework 12.